Yeah, welcome to the next episode on substitution by method for integration. In the previous video, we looked at indefinite integrals, and this time we're taking the definite integrals by substitution. I hope you've been able to try the problem of the day out and you had the right answer for me. Thank you. So let's start with the definite integrals. Definite integrals, as we know, it means that there's a limit of integration provided. Let me change my pen to blue. Limits of integration provided by a and then b. Okay, where in that case, if I want to evaluate it, I have it as big F of x to the limit b and then a. We still want to change or move from one variable x to the another variable u. It means we transform every other term in the function respect to u. One interesting part with a definite integral is such that we are not just changing f of x as in, and then the d of x to some f of u and then d of u. Another interesting thing we have to take note is that the integral a to b of x, and it has to change respect to the u limits. Okay, so if this was x limits, then it's going to be something like c and d for the u limits, and that is what we would term it as change of limits for definite integrals. So let's take a quick example to help us understand what we have to do. Given this integration to do, okay, you know I can integrate this by substitution. If someone says I'm going to expand this to a power half and then apply something else, it's not going to work. So you always want to use substitution rule. Okay, and so what one are you going to substitute for? I'm going to take the term under the square root. So u equal to this, it means that my du dx is simply 2x. You realize that there's something we must cater for. Always be smart when it comes to your substitution. Okay, you realize that I can see 2x dx here. It means that 2x dx is simply the u, that is all, or the u is 2x dx. When you're not done now, we must change the limit point given. At x equal to 0, what do we get for u? Don't forget u is here, so equation 1, equation 2. I'll substitute this as equation 3. It means that my u is going to be 0 squared plus 1 squared, which is 1. At x equal to 4, I'm going to get 4 squared plus 1, which is 4 squared is 16, right? Plus 1 is 17. Okay, let me check my slides if I'm right. Yeah, so I'm right, it's 17. I'm taking it from equation 1. Okay, so it means that this entire integration now becomes 0 now becomes 1, 4 now becomes 17, this integral now becomes square root of u, and then 2x dx simply becomes u. That is from equation 2. Okay, I don't know, I'm going to trace the line for you, but no, let me not just do some tracing of line. I'm substituting equation 1, equation 2, and the limits here 3a and 3b into the general thing. So you realize that now this becomes something simple to integrate. This is same as integrating 1 to 17 u to the power half du. The square root is half, and then from here you can simply do your integration. I'm going to add by the power rule. I'm going to use the power rule here, so it's going to u half plus 1, and I'm going to divide the half plus 1 here, and then evaluate at 1 to 17. Here we don't add a constant c because we have a definite integral. I believe this is going to be 2 on 3 u, 3 on 2, 1 to 17. But the question is 1 to 17. You can quickly do the substitution, and then whatever you get, it will still be in terms of u, and then what do I get for my final answer here? I had 46.60. Please take your time and then do the substitution to see if you're going to get what I'm expected to get here. Okay, so that's going to be 2 on 3, 17 to the power 3 on 2 minus 1 to the power 3 on 2. 1 to the power 3 on 2 is simply still 1. And so you check the others. And that's it. Let's take a second example. If I have to integrate the function given, how do I go by that? Now there's definite. Okay, so I'm going to set u to be x squared plus 1. It means that my du dx is 2x. And I see something here. This 2x dx is here. It's simply du. It's just like the first example I just took you through. Now we must change the limit as well. Why? Because I have a definite integral. So at x equal to 1, u will be 1 squared plus 1, which is 2. At x equal to 2, u is going to be 2 squared plus 1, that is 5 from equation 1. I'm going to get this one from equation 1. Okay. So it means that this whole integral, now 1 will become 2, and then 2 is 5 here. This inner limit is u. This whole term is just du. As simple as that. See how the transformation makes life easier with the integration. So by power rule, I'm going to get 1 over 2 u squared 2 to 5. Okay, and that gives me 1 over 2 5 square minus 2 square, and that should give you some good answer. 5 square I think is 25 minus 4, 2 square is 4 all over 2, and that is indeed 21 over 2. I was able to convert this one easily than example 1. That is how definite integral works, as simple as that. And so let's take the problem of the day. Here we are looking at a work done by a variable force. The work done by pushing an object from its rest to some distance, 2 meters. 0 means it was at rest. There's not been any push or any force applied. When the object moved to this point, it has been moved. There's a force applied to push it. Okay. And so we said x is a distance covered. The force acting on the object is given by this function. So given that I covered 1 meter's distance, it means the force applied will be 6 times 1 square plus 4 all to the power square. This is 6. 5 square. 5 square is 25. 25 times 6 Newton or joules will give you the force applied in 1 meters. But that's not it. We are asked to find the work done when the object was moved from distance 0 to 2 meters, and that's where integration comes in, because we are accumulating over time some distance. So integral 0 when the object was at rest to 2 meters, the function dx. So that's integral 0 to 2, 6x x squared plus 4 all squared dx. Which of the substitutions are you going to do? This is a definite integral, and so first you must set your u to something. You must find the u to be something else. Alright, and then you must check when x is 2, what is u, and then when x is 0, what is u, and what will be your new integral. And then that is it for the day. So find the force or the work done when it has been moved from 0 to 2 with the use of the substitution. In the next video, we're going to take the last aspect of substitution, that is using the trig inverse identities. Stay tuned.